Hi everyone, let's have a quick look at this substitution question by integration. So it tells you, I'm going to write this one side, I'll write it in a different color, we'll follow through. So basically if it says here x equals, we're using this substitution, 2 sine theta. Now before I even start, I'm going to do dx d theta, do this straight away. So sine goes to cos, so that will be 2 cos theta. Okay, so we've got that already. Now let's start substituting things in. So I'm going to keep that root 3 and 1. Now don't forget these limits are to do with x. I'm just going to put that because I'm going to change the limits later. Okay, because I know that x is equal to that, and I'll show you how we're going to change the limits there in a second. Now first of all, let's do this. 4 minus, now x squared, I'm just going to write it here, x squared is the same as this squared, which is going to be 4 sine squared theta. So that's the reason why they chose that, squared theta. Just got to factorize that in a second and show you why they use that. In fact, I won't factorize it, I'll show you straight away. And I'm going to do 2 steps in one go, so I'll sub that in there. I'm also going to say that dx, if I multiply that up, that dx, just write it here, is the same as 2 cos theta d theta. So I'm going to change dx for 2 cos theta d theta. And this is important because when we're integrating here with respect to x, everything in this expression has to be in terms of x and constants. And when we changing it to d theta, integrating with respect to d theta, everything here has to be with respect to theta, including these limits. Okay, so now before I carry on, I'm just going to change this now because I've got causes there and I'm telling you why they use that now. I'm going to change this color so you can not get confused here. So you should know that sine squared theta plus cos squared theta is equivalent to 1. So if I multiplied everything by 4, that is also true. Now if I take that to the side, I'll get 4 cos squared theta equal to 4 minus 4 sine squared theta, which is exactly that. So I'm going to replace that expression with 4 cos squared theta. In fact, I'm going to do one better, and I'll just do it here. It's okay. I'll do it in steps so I don't confuse you. So that's going to stay. And what I could do is, yeah, I'll do that later too. Don't forget this is limits of x. That will become 4 cos squared theta square rooted multiplied by 2 cos theta d theta. Okay, all is becoming easier. Don't forget these are x limits, which I'm going to change now. So talking about x limits, if that is the case here where x equals 2 sine theta, if I want to find what theta is, I'll reverse this, so that will be x divided by 2 and then take the sine over, which will be sine inverse, and that will give me theta. So I'll say that again, x, you divide that by 2 and take the sine by inverse, and it gives you theta. So now if I put root 3 in there, okay, so if I put, I'm just going to do that quickly here, so theta of sine inverse of root 3 over 2, that should give me 16. I'm just going to double check it. That's the exact answers anyway, so I'm pretty sure it's 60. I'm just double check it here. Yes, it is. So that's, I'm just double checking it once in terms of radians because you got pi there, and when you're doing integration you want it in terms of radians. So if that is 60 degrees you get in on your calculator, just put that over 180 Okay, so that will be over 180 rads. So that will be a third pi. Okay, so I'm going to change that in a second. And if I want to put 1 in there, so theta equals sine inverse of x is 1 over 2, and you should know this is a common one, is 30 degrees. Again, changing it into radians, divide it by pi and times it by, divide it by 180 times it by pi. In radians, that's the same. 2 pi is 360, pi is 180. So these are equivalent fractions, and this will be 1/3, no, 1/6 pi. Okay, 6 to 18, yeah, which is half of that. So now my next step, just because I want to save some place, actually I'll do this in red now. So this root 3 will be replaced by 1/3 pi, and this 1 will be replaced by 1/6 pi. And this, when I square root this, I'll get 2 cos theta times 2 cos theta d theta. Now 2 times 2 is 4. I can just take that out. Okay, so I'm going to put that out, 4. And actually, yeah, I'm going to leave it in at the moment, because when I replace this, I'll tell you why, so ignore what I've just said there. So if I go here and leave that as 1 pi over 3 and pi over 6, that's another way how you could write this. And I'm just going to leave that as 4 cos squared theta d theta. Now you can't integrate that at the moment, and what you need here is double angles. Okay, so you should also know this fact about double angles, that you should know that yeah, you should know that cos, will you use cos? Yes, I am. Cos 2 theta is the same as now that's going to be cos squared theta minus 1, so that's going to be, because you get, I'm just going to do it in long terms, so that's going to be cos squared theta minus sine squared theta, and if I replace that for 1 minus cos squared theta, that will give me 2 cos squared theta minus 1. And if I rearrange this, take that to the side, I'll get cos 2 theta plus 1 equals 2 cos squared theta. Okay, so hold that thought, I'm going to put that into there. However, if that's 2 cos squared theta equals that, if I double this, I must double everything here. Okay, so I'm just going to replace that. I'm going to actually take the 2 out. Now if I take here, if I take a 2 out and replace this by 2, because 2 times 2 is 4, I'm still going to get 4 cos squared theta. And now when I've got 2 cos squared theta, I'm going to replace 2 cos squared theta with that. So I've got 2 outside, because I'm going to double everything, double all this. Keep my limits there, which I've changed to in terms of theta, and 2 cos squared theta is going to be replaced by cos 2 theta plus 1 d theta. Okay, so almost there. Just give me 1 second. I'm going to get a division line here so I don't confuse you. Put a line. Actually, if I do that in, no, not that one, sorry. So put that along here. Now I'm going to put one along here. Okay. Right, let's use a different color. Let's use green. So now I'm on this process. Now I've got everything I need to integrate, because I've got everything in a single trig function, and I've just got constant there, and I've got another constant outside. So I'm ready to integrate now. So keep the 2 outside, and I'm now going to integrate. So the integral of cos 2 theta, now if you think about it, sine goes to cos. Okay, so the integral of cos is going to be sine, a positive sign, so that's going to be sine 2 theta. Always think about differentiating. Sine 2 theta will now go to cos 2 theta, and then you times it by 2, so you need to divide this by 2. You need to do the reverse. That's the way we integrate here. So if I differentiate cos 2 theta, I mean sine 2 theta, I'll get cos 2 theta, then times it by 2, the 2's will cancel, and that will cos 2 theta. So I'm happy with that. The next one is going to be plus 1, that's just straightforward theta, and we're done. And then we just put the limits pi over 3 and pi over 6. Now you have to show all these steps. It's best to write these down too when you're showing all these steps and see how that goes. Actually, I needed a different color now just to finish it off. Right, so put the 2 outside and let's sub in some values. Put this in first, the upper limit. So I mean, you can put it as radians, so if you think about degrees, this is the same as 60, and if you double 60 you get 120, and sine of 120 is root 3 over 2. So if that's root 3 over 2 divided by 2 plus pi, this is the same as that, over 3. So I'm going to put brackets around here. That's going to take away the lower limit. Now put this in. So that's 30 degrees. Okay, so 30 degrees. Put it in there. We know that that's 30. Double 30 is going to give me 60. And we already know that 60 is root 3 over 2. So you're going to get root 3 over 2, which again is divided by 2. Okay, and then here we got plus the same as this, pi over 6, close bracket. Okay, now what you could do now is just that 2, you just bring it down, so that's just going to give me, so whenever you got anything like that, you just bring it down, and that would just give you simply root 3 over 4 times top and bottom by 2 if you want, get rid of that, plus pi over 3. I'm going to take this out of bracket. That is the same as that calculation, so that's going to be a minus root 3 over 4, and that plus becomes a minus pi over 6. Okay, just double checking something here. Oh yeah, I'm happy with it. Okay, so now they will cancel. They will cancel with each other, and you will end up with pi over 3 take away pi over 6. Now what you could do here, make those equivalent, times top and bottom by 2, so you'll end up with 2 pi over 6 take away pi over 6, so you just end up with pi over 6. And if you double that, you end up with 1/3 pi, as required. Okay, so that's what we wanted to show. Okay, hope that helps. Make sure in the exam you write this nice and clearly. Put lines if you want, and you'll have no more pages to write down underneath if you want, but show you're working, show what you've done on the side, and you'll get marks for those. Okay, especially for these identities. Okay, hope that helps.